Hi guys. Looks hot,
Hi.
Martin.
Well, it's pretty rainy and gloomy still, but
Okay.
it's just better lighting here. I'm I'm
Okay.
not not I'm not at home, so the light is much better.
Okay.
Someone actually asked me whether I got a new camera.
Yeah, and a new flat as well.
Yeah. No, it's my parents.
Okay. But still Netherlands. So
Oh yeah, it's pretty nearby, but they're on holiday, so I'm sort of using their apartment as an office.
Oh, nice.
Right.
Also, when you get out.
Yeah, definitely. It's not even like it's just like going somewhere in the morning and getting back at the end of the day. That's a good change of scenery sometimes.
Yeah, it's it. I think that's the best way to actually, if since I work from home so much, it's nearly impossible to stop working because it's the same anyway. So why
Yep.
stop, right? It's interesting. So why stop? Yeah. Okay, I think it's just the three of us.
Yeah.
I
So
pinged I
we can.
pinged I pinged Kamel.
Okay.
Just
Yeah.
it's but yeah, if he comes he joins. We can
Otherwise,
just
we can decide on the whole spec today, and then it's just final. So we have 3 votes.
but I think he was also okay. Like from the discussion.
Yeah,
Um,
I'm not sure if you had made a comment about the new specification idea, but the one with the relative paths, he was keen on. But
I
same
think
thing.
he left some reactions, I think, on our discussion that
yeah.
seemed to indicate that he was okay with it, but he didn't directly respond. So
Counted as a yes.
Yeah, I mean, his main point was that he didn't want to have full passes everywhere,
Yep.
yeah.
and I think actually the thing now is like will not change anything syntax wise, right? We basically stick with the same AST
Yeah.
that we have. It's just semantics that you have these relative.
Yeah, and
Yeah.
what I realized is that the list case is, I think, anyway not in the spec. So once we add this to the RFC, then I think we can also just add the same thing also works for objects, and then we should be fine.
Yeah. Yeah, I mean, I really think it's sort of it's a fairly consistent design this way. There's a clear separation between the input and the output.
Yeah. I mean,
Yeah,
the
but
only
what I was not keen on, I have to say, was variables
yeah,
in there, because I think variables could play a role later, and
Yeah.
putting them in now for something like something trivial, like referring to the current scope, would have wasted them or
we
reduced our flexibility for later.
we could use variables, for example, in the future if you want to do this. I wouldn't say that this is even version 1. To indicate that you actually want to have a root path in a scoped selection, but for example, $root or something like this. But
Yeah.
that's not,
It could be lots of things.
yeah, I mean, for the objects, it's always possible to refer to the root when you do not do the projection with this or this scope.
Yeah.
Lists, it's not possible at the moment.
No.
But
No.
I
But
don't
but
think-
that makes sense. I mean, the semantics wouldn't really work out.
I mean, what I could imagine that maybe you have a list and then you would want something from the parent as a member in all the cases. I could imagine that this would in some way be a use case, but I don't think that we should worry about it now. I think we should worry about it once we have someone complain that they cannot do what they want to do. Then
Yeah. Yeah, I mean, I think we've all seen the spec. Do you want me to like walk through the examples so we
I
can
mean,
Yeah, let's go.
have
Let's
one
go.
more check?
Yeah, let's go one time through it.
It's recorded, so if someone wants to watch it back, then they also see what we discussed because the Slack is not.
That's a good point. Yeah. Let's see if I have it. I think this is the right screen. They keep changing the Zoom interface, but Can you see this?
It's still the best
Yes.
best app
Yes.
best app for video calls.
So I've been using require here because that made the example like make more sense. But it would be exactly the same for is. It's just that the object we're interpreting against is different, of course, because here it's the object the field is defined on. So obviously we have simple field references, like mapping a product.weight field to a weight argument. Doesn't have to be the same name. Could be a different name. Doesn't have to be defined directly on the type. Could be any path that returns sort of the right a value of the right type. And then there's the more complicated cases. It's like the input object case. So we've already talked about the object constructor syntax. That's what I've been calling it. Other naming suggestions are welcome. But I think we do need a name for this. So the idea is that here we have a dimension input object. So we need to map values to the shape of object. Here we're constructing that object from two fields on the product type, width and height. And this is the shorthand. I suspect in many cases, like the shorthand will be what people start out with because often the field name is the same. But it is a shorthand for the more explicit version where you have a label. So the label part always refers to the field in the input object. And then this is just an expression that provides a value for that label. Obviously, you have to use labels if the names don't match. And then here, if you have a like a nested object on product that also happens to be called dimension, I don't think we want to sort of allow directly mapping to that object and implicitly mapping the fields. So my suggestion would be to always be sort of require an explicit mapping.
Yeah, I think that was also the sentiment, like with everyone last meetup.
Yeah,
because otherwise you don't know what will end up there, like between changes of both of the types.
exactly. And you want to be able to validate that you get the result you expect. So this is a fairly straightforward extension of sort of the syntax that we discussed before. We still have a label similar to the simple case. It's just that the expression on the right-hand side is now a path expression. And that one, of course, is similar to this case. So things do build on each other. We have an expression and an expression sort of refers to or evaluates to a value. In this case, that value gets assigned to the width field of this constructed object. The naming here isn't directly related to the naming of this argument. I just wanted to make that point here. So this expression obviously doesn't have to be, has no relevance for sort of the output structure. And I think this is the new part. So this is still just an expression in my mind. So this doesn't actually change anything about the output structure. It's just that what this returns is not a simple scalar value, but it returns an object. But it returns an anonymous object. And in this case, we sort of directly assign that to the dimension field. But again, there's no relationship between like the naming of the argument and the path element here.
And the new thing here is that it's not on a list. but now also possible on objects. Okay.
Exactly. Yeah. So I think we have sort of a fairly consistent notion of a path expression here, and a path expression always evaluates to a value, but that value can be either a scalar, like in size.width, for instance, can be an object expression in this case, and as we will see later, it can also be a list. So this is what we discussed before. We don't. I mean, an expression like this doesn't really make sense. Like if you're referring to a like list valued expression here, you can imagine an interpretation of this, but it quickly becomes fairly ambiguous, especially if you refer to different lists in here. Like, would that be like the Cartesian product, or what would you be doing? So I don't think we want joins in our syntax.
No.
This is the syntax we discussed before, and it's consistent with this syntax. It's just that because the type of dimensions is a list, the type of the value that it evaluates is also a list. But it's built out of the exact same constructs that we saw before.
I think about this a bit as a scope in a programming language, right? So when you do a map on dimensions, then the lambda that you give into the map function would be in its own scope.
Yeah.
Scope rooted is the context of the expression before the map, right?
Yeah. Yeah, and if you extend like in some functional languages, the notion of a map is actually more like more general. And in that case, like you can even argue that this is a map. This sort of maps the value of dimension over this object constructor.
Yeah, it's basically this. You give in the upper example, you basically give one object into that function, and out you get what we specified there, the map, the object. And down there, it's with dimensions, it's basically an for each over this, and you invoke for each element the same map.
Yeah.
So
yeah, but I think we can formulate sort of fairly consistent evaluation rules for this. Like the object constructor syntax, it has its own evaluation rules. It gets an input, it outputs a value, and
yeah, we can formulate that as a function in the spec.
Yeah, there is not really a good analogy for it from well-known function. We could theoretically define it as map, because it's definitely not a flat map, because a flat map would make the output. I mean, that's one issue that we have, which is not covered by this, but it's also something that we really shouldn't care about. It's when you have nested lists, there's no way to reformat it. And I don't think that's a use case that makes sense, because you anyway, in 99% of the cases I can imagine, you would want to have a nested list also mapped as a nested list. For example, when you have coordinates.
I think this would work.
Yeah, but you cannot flatten it, right?
No, but you can flatten it. No,
but it also it's. I think it's not something that we should worry about, because that just adds noise now, right? As said, it's the first version of the specification. If it's extendable, if we say that this works, if we want to, I think we need a use case first to really understand the issues that people would have with nested lists.
Yeah, I think we could in theory extend it with like you could even do something like this, right?
Yeah, I wouldn't go there now, but
no, definitely not. But I think
it is possible, yes.
Yeah,
and that's why we should. That's why we also should not introduce things like dollar at the moment, or things like that. This is our future space for innovation.
Yeah.
Yeah.
I also like that there's, oh, sorry, it goes further. Go ahead. Let's talk about it later.
Yeah. I mean, this is just basically illustrating what we saw before in more complex examples, like the fact that you can nest all this, and you can still interpret every piece sort of the same way it was used before. So in this case, like we still have an expression here that evaluates to a constructed object with width and height field, an input object. We have a size label, and that allows us to construct this like complex package input. And weight here is the shorthand. Here we don't have a shorthand, and I think that's the only like slightly like point where I'm still not entirely sure. Like definitely, if the naming is different, you want an explicit label. This still feels a bit superfluous, but there are issues with the with allowing a shorthand here.
Yeah, but it's also like having there a bit more syntax at the moment also gives us the chance to remove it later. But if we have any doubt, let's keep the long version.
Yeah, no, I agree. That makes sense. What did I want to say here? Oh yeah. So of course, we still have the ability to sort of nest things that aren't normally nested. So this is like syntactically a subtle difference, but the semantics are very different. Because in this case, width and height refer to like product.width and product.height. So this is something that I think we will need to educate people on, because it's a fairly subtle distinction, and hopefully we'll get editor support for this, and like syntax coloring would help.
Yeah, I mean the language piece here is so small that the language server is actually not too hard to implement. So we should have something quickly for this. At least something rudimentary that works in VS Code. I mean, you guys also are VS Code based, Monaco based, with your stuff.
Yeah.
So...
Yeah, and there's different levels of support, but ideally it would be schema aware.
Yeah, that's why I say, like, you want that in the graphical language service.
Yeah. You don't really want to have only the tree-sitter stuff. You want to have like proper syntax support. But we can also say that in the first version, we just add the syntax highlighting, and then later add the proper language support.
Yeah.
Yeah.
I mean, I think like syntax highlighting already makes it much easier to see sort of what the input and the output parts are if you like color them separately.
Yeah, I think the value of having more than syntax highlighting is not really only to have like IntelliSense and stuff like this. It would be really nice to have just like, if you do something wrong, something that is syntactically incorrect, that it already tells you that it is, and then later that adds the proper language support with validation that width actually matches with width and whatever. But
you realize you will need, like, for a language server with IntelliSense to work, this needs to have access to the
that's exactly
to
what
the schema registry or whatever you have behind that, because it needs to have the other schemas.
Yep, that's exactly what I was thinking about in this second too. You have to have all the schemas to make it work.
That's possible.
But you have to make how do we call it? Actually, it's difficult. It's really difficult. You have to do the composition first.
No, you don't have to do the composition, because like, it's not transformation that you have in there. So technically, you can. It just refers to subgraph schemas, but you need all of them.
Yeah, but
there.
to get them into one schema, which works with a language server, you would have to do the composition first.
Anyway, let's. I
Yeah.
don't think it's so difficult, but let's discuss that.
Yeah.
In a separate.
Yeah, I mean, this was just like the only syntax for shorthand that did make some sense to me, like the idea that this would be, because basically we have the notion that like if the field name is the same as the label, you can sort of leave out the label. This would be a similar shorthand, leaving off the label. The problem with this is that it becomes a lot more, becomes a little bit ambiguous if you have multiple levels. And you could disallow it in the case of multiple levels and allow it in the case of a single level. But yeah, maybe we should park it all together.
Yeah, I'm still not 100. Is there more? Should we finish first?
No, I mean this was just like the other, like,
yeah,
the other possible syntax, but I don't think we want that.
Yeah, in the end, I don't care really if it's the dot prefix syntax or this one. The good thing about this one is that it reuses a concept that we already have. It just has different semantics, which it is cleaner and also means less work. So that's good.
Yeah.
What I'm not 100% sure is if you scroll up where you said that we do not want to allow complex type directly mapping, this one on line 24.
Yeah.
I'm not sure if this is something that you should be allowed to do or not.
It's not allowed.
Yeah, I know that it says that it's not allowed, but in the end you have the composition around it that will tell you when something breaks anyway. So from an evolution standpoint, it's more or less the same, right? If you want to add, if the type matches, it would just work. If the type in the evolution change and they stop working together, then you would get a composition error and you would say that it's if someone added a field and now it doesn't match anymore. So
but it's less clear why. Like you will get. I agree. In the end, we compile, but this way it's also visually clear what's happening. Like you look at these directives in your subgraph and you already know what it will exactly map. And there's no like leakage of data because now somebody on another subgraph introduces something that is now injected in your subgraph, for instance. Because you have here a requirement. And this dimension input could have other fields. But you should have here a clear intention of what data you want to inject into your service.
Yeah. And that's not just a matter of like evolution. It's also a matter of efficiency, or for like query planning. Like we want to know exactly what fields are required, and here you'd have to, like, in these cases you always know exactly which fields are required, and here you'd have to, like, every time sort of perform that mapping, translate it into a fully complete mapping before you can do anything with it.
Yeah, you don't want to select star essentially. And that, I mean, that is that plays very well with GraphQL. In GraphQL, we want to always specify what we want, and that's the same thing here.
Yeah, I mean, the subtle difference is that the select star would be exactly what you would want in this case, right? That's the only difference, the only argument I can make there. In this case, you would want select star because you have a specific. You have a specific definition on both sides, and they have to match. Otherwise,
so they don't. I could have here dimension input. Maybe I use it in several places, and maybe I have like 5 properties on here. They are not required properties, and at the moment I want to just select 2 here that will inject data into this.
Yeah.
I'm not saying that is the best design to do it like this.
I'm saying there's always a case where I'm saying if you would do it, right, it would be an one-to-one mapping between the output type and the input type. That's the only thing I say. The reason where I see this as useful would be when you have an API where you have a lot of stuff like, you know, let's call them structs. You know, when you have, it's not a scalar, but it's always going to be the same object for input and output. For example, when you have points or stuff like this, then you would just have to specify that you want to map points and you're good. But
Yeah,
I don't mind not allowing it because it makes it extendable. So let's be more strict in the beginning, and then once people get angry, we can still loosen it up.
agreed. Yeah, and I mean, who knows? Some kind of struct proposal might make it into GraphQL at some point.
Yeah, it's in the works, but I think it will take more
Does
time.
it have a champion? Otherwise, maybe
It's Benji.
Oh, okay.
Benji wrote the proposal. I mean, but it has a lot. But different topic. There is one thing. Did we consider allowing constants like literals in this first proposal? Is that something you want to have in the object?
I think we left arguments out of it altogether.
Okay.
But if there is I mean, I think it's a fairly straightforward extension to allow at least literals. I can imagine that being useful.
I mean, I really don't.
Even for the Star Wars API example, like selecting the unit of weight in the mapping, I think that might be
exactly
an example.
Something like that. Because sometimes you have these constants that you need to inject.
Yeah.
And
I know that people sometimes, no offense, butcher these features in Federation where they have like really complex requirements to share data across different subgraphs. Do you have any idea if they sometimes, for whatever reason, also do this with connections, where you have lists that you want to share across services?
I'm not sure if people. I mean,
it's not really a use case, right?
It's likely someone out there.
Yeah, true. Yeah,
is using it in that way, but
I mean, I just ask because maybe you say like, oh yes, this is a use case because of, I don't know, an aggregation service or something like this. Who knows?
No. I mean, people do like pass through pretty complicated data sometimes. I haven't seen connections specifically, but I can imagine if that's part of your schema, you might need them at some point.
I think that this is a problem that not lists, but passing bigger object structures between services, that's a problem that we definitely should solve somewhere in the future, but also not worry about. But I see
but also how I'm always like, there could be arbitrary context data between services. And this is something I know a lot of people want. Like what you have in GraphQL, you can pass into the execution. And something that you
broke
could
up a
share
little bit
outside. Oh, sorry. Yeah, in GraphQL, you have sometimes you have this context that you can pass into the execution, right? And something on a distributed scale where you could do that is also something I'm.
And we have an existing sort of isolated feature for that. I'm not sure if you've seen that, like the from context.
But this is more selecting from the data, all right?
Yes. So the idea is that the notion of context could be more general, and what this allows is sort of path dependent, like passing data to children, basically. Sort of a dynamic scope. And that already addresses some of the use cases that people currently abuse keys and require for. But you're right. There's other contexts that you might want to have filled in by sort of external services or.
That sounds like a nightmare for the satisfiability rule.
Oh yes, definitely. It makes. I mean, this is a whole separate discussion, but we've been involved in a little bit of performance tuning, and it's actually surprising how little sort of the path depth affects performance. I would expect that to be like a bigger factor, but it's definitely the notion of satisfiability is sort of it's very generic. And it really asks you to consider sort of every possible path through the graph, and in many cases, like most of the path doesn't really matter. Like once you hit like an entity, and you have the keys available, there should be no need to sort of perform the same validation again for every path. But with context, you're now introducing path dependence into the model. So it definitely complicates things, but it is useful. It is something that people like often need, sort of the path you use to reach something that often tells you something about the context you're sort of interpreting it in.
The problem is only that in this tree that you have in GraphQL, you only can look ahead. So that's what makes it complicated, right? We have in Hot Chocolate, in the server itself, we also have scoped context data, and it's also widely used. A lot of people use it, but in many cases, it's like, what happens if this type is used somewhere where you do not have the context data? Then
yeah.
And
I mean, from that perspective, this is actually this is a safer mechanism because it brings the notion of context into the schema, and allows you to validate sort of the satisfiability beforehand. Like it actually tells you if there's a path where certain context data that you depend on isn't available.
Yes, definitely. Yeah, what I meant, what I see is that with the complex requirements, I mean, as I said, that's future as well. It's like sometimes you need data from somewhere else and from a different subgraph. And with this being in the actual implementation, for example, when you, create an order, you have to verify the products and stuff like this.
Yeah, that's something I sent you at some point, like for instance, for mutations, right? Could be you're invoking a mutation, but this mutation needs to verify something. So you need to do an actual query somewhere.
You do this call nowadays, you do this call anyway. And then you end up with either you do a GraphQL query from the subgraph to the other subgraph, which can be complicated. Because then you also have to do a client versus queries, whatever, and so on. And then the other option is you have a different API type, a REST or gRPC, or you have where you fetch the data, or you have access to the same database, which is also not really nice. If we can solve this on the graph level, a lot of headache would go away from people because they don't have to worry about getting this data. It's just there. And in the distributed setup, it's also no problem that there is no, distributed transaction around it or whatever, because you anyway have to design it eventual consistent, because that's just, it doesn't matter if the gateway aggregates to get the data or you do it manually, you have the same issues. It could be that during the execution, the data has changed or this product doesn't exist anymore or whatever. So that's something that can happen anyway. So if we add this to the distributed setup, that would be really, really helpful for people, especially in mutations.
Yeah. I mean, so some kind of notion of a subquery. I think that's basically what we'd be asking for. But maybe in a way that like doesn't force you to write complete queries. Like,
yes.
In line,
exactly.
But maybe like a notion of like basically prepared statements or something. In a database sense.
Yeah, it's still it should be still.
You cannot call it that though.
No.
But it should still be a requirement, right? And it should still fit in our model. If you're starting really writing full queries, then you could also just call use fetch and call and just fetch the data, because the complexity level would be the same.
Yeah, I think that's not quite true, because you don't have to manage the subqueries. You manage it all in the gateway. So even if you would have to specify full queries, which we wouldn't want to, but if we would have to, you would still win in the sense of you do not have to worry about having another graphical client that consumes a subgraph, because every graphical client adds a certain amount of complexity.
Yeah. Well, and it might not even have direct access to the subgraph, or you might need data that comes from multiple subgraphs, or you might need like authentication data or context to be passed through. So there's definitely like making the router sort of handle these subqueries, I think, is definitely preferable. But there are different, like, various mechanisms you could think of here, sort of that decide sort of when these queries are performed and how you like get access to the data.
Yeah, but it's also future stuff. For now, let's get the first.
Yeah.
Let's get version 1 out.
The first.
Okay, so
specification
next steps is then Pascal finishes off the spec text with with a couple of these. We should have these examples in there, Pascal.
Yeah, I really like the way that you presented them. It makes them a lot more approachable than having a full schema, because for each of the examples, we would have to have all the types defined to make sense. But if you just have a comment that explains what this means, it makes it really concise. So I will, if you can post this into the slide, I think you already did.
Yeah, it's the same text I posted previously. Yeah.
And I will read.
Yeah, although I wouldn't do it as an example, as a comment, Pascal. It's like in the specification text, we always have like the example, and then there is a follow-up text or an introduction text.
The problem is just that if you have to define all the types that are used in there, you mean
you don't have to.
Yeah,
you don't have to.
You mean the comment is just
the
proper text.
Above. It's not a comment in the just so that we
no. That was just so syntax highlighting wasn't getting confused.
No, it's just for the spec, but we should have like and there should be also maybe 2 more or 3 more examples that don't work out. Like, so it's very clear what works and what not. Yeah. And then we can finish off when the syntax is ready, we then can also finish off the directives, and then we can really start with the next block of directives.
Yeah, and I wonder, because I think like we've been talking mostly about is. All of this also applies to require. Yes. I'm not sure if there's anything like apart from sort of deciding like what the context is under which sort of the expression gets evaluated. I don't think there's anything specific to require that we need to discuss.
That's why I work most on is, because like it's the same thing. Like the data context is the same. It's basically the return type. That is our mapping context from which we map, and then it's the same argument we inject into, right? It's the same mechanism. That's why it's also so nice to have kind of the synergy there.
The type scope is different. It's not the return type in require. In require, it's the type.
It's you're right. It's not the return type. It's the outer type.
But it's very easy to describe it. It's at the moment in the spec described this way because I was more focused on syntax. After I read it the second time, I think that this completely was lost. We have to specify, I think Shane even commented on that, we have to specify what the context is, and once we have the context specified, we can also explain what the scope context means, because that's exactly the same thing. It's just the context in these curly brackets is just a different type.
The initial context, yeah.
And let's see that we get this in for the next meeting. Next meeting is the primary meeting.
Yeah.
Also, it says this is the primary. I already talked to Jeff and Benji. Let's move to the next week, and then we can hopefully sign off on this block and start with the next. Because we need the other directives in to start with the composition.
Yeah.
But I think like this is the biggest, for me, it's the biggest block where the biggest complexity was in, like the whole lookup and require proposal. The other
I think satisfiability is another complex block.
I'm just talking about the directives. Like the other directives are less contentious. Like shareable is less contentious. Like I think the rest should work quicker through to get agreement on the shape of the directives, and then we can start with the composition.
Yeah. I just remember the formalized version of the satisfiability rule I sent you. It's actually quite easy because I played around with a bit of algebra and this analysis stuff to just try to formulate it in a mathematical way because I just thought it's fun. And the satisfiability rule is really easy. It's just when all the valid queries when all the queries in the set of valid queries pass the execution, then that's viable. So
yeah, and mathematically, like infinite sets are not an issue.
Yeah.
One liner.
Yeah.
Yeah. So
I
think we don't quite deal with like infinite sets, but like even even like just valid paths that does get complicated quickly.
Yeah.
But I'm happy that we move forward with this because then we can start with the more interesting stuff. I'm really looking forward to the composition. We already have a bit of composition logic, but I think we can't probably not of specification. I don't know how much we can reuse because we made a few shortcuts. But
no, I think the merge rules from the algorithms should pretty much match up with what.
I think the merge rules should be fine. And I think we also have started on the validation there, and I think we have.
But we go through it the same way we did with the directives.
Yeah, but we have to start doing these when we go to composition. Once you have the directives, and we go to composition, we have to do the composition rules as a whole block, or like if we work on 4 or 5 in parallel. Because if we do them one after another, then we'll not be finished for the next 5 years.
No. I think we need to separate it into like phases. Like we have we discussed before, you have like subgraph validation, you have merging, you have supergraph validation, and you have satisfiability.
Yeah.
Awesome.
Exactly.
I was saying,
okay, awesome.
One thing what I will do, this will mess up all the comments, by the way. I did a mistake and I did line breaks in the specification. Glenn told me that this makes it nearly impossible to propose changes because they always will jump around as soon. I lined them on 100 characters because that was very dumb from me because now we can hardly do changes. I will change the formatting at the block about the scopes, and then I will ping you, then you can review it. And I think we should be fine to kind of sign off of this next week and then start with the new stuff.
Awesome.
Sounds good.
Okay.
You have anything else? We don't even have something on the list, right? Okay.
No, I think this is plenty. Let's get this through first, and then we can go on to the next topic.
Sounds good.
Yeah.
Cool.
Awesome.
All right. Well,
see you guys.
See you next week.
Bye.
Bye.